All right, functions. Today we covered compound interest, but really what we're going to be talking about is giving you a formula, an exponential formula, and you are going to put all the parts together and put it into context. So, or you may need to solve for some of the variables that are in that formula. We are just going to use compound interest for the purposes of that to kind of learn that skill, but that's all that this is. So if we have a compound interest formula, and most of you know that I teach financial literature, so you know that I use this formula a lot. This is the formula that we're going to use. So the A in the formula is going to be your ending balance. So you're going to start with a P, a principal in dollars. Typically that is a starting balance. That's your starting amount. And then you have an interest rate. So the interest rate, I will say you need to be really careful with that R because you want to write it as a decimal. I'm going to give it to you as a percentage, but we need to write it as a decimal. So you're going to have to do some converting. N is the number of times that are compounded per year. So if it's annually, that'd be 1 time. Semi-annually, which would mean every 6 months, so 2 times a year. Quarterly, 4 times. Monthly, 12. Daily could be 365. So it could be any amount of time. So what we want to do is make sure you understand that N is the number of times compounded per year, and then your N and your T, and T is in time, T in years. So make sure you get this in, and we're going to talk about how to use that. So here's our first example. So we're going to find the value of an account that starts with $2,000. It has a 5% rate. It's compounded annually, and we're going to find out what the balance will be after 10 years. So what we're going to do is we're going to figure out what our A, P, R, and T are. So if we do that, we're going to use that compound interest formula right here. Our principal is 2,000. And we're computing, by using these numbers, we're computing the A. So that's what we're finding. So our principal is 2,000. Our rate is 5%, but remember we want it as a decimal. So it's going to be 0.05. Remember when we have that percent sign, that just means to divide by 100. So if you can't remember. And then annually means it's only going to happen 1 time a year. So our N is going to be 1. So we're going to plug all of that into our formula. The best way to do this, especially in our calculators, is to figure out what is 1 plus 0.05 over 1. Well, that's just going to be 2,000 times 1.05 to the 10th power, because 1 times 10 is 10. Then we're just going to plug that into our calculator, and we're going to get roughly about 3,257.79. Now, we just need to put our answer into context. So when we put our answer into context, the account is going to be valued at about $3,257.79. One thing to note is in context, we would always round to the nearest penny because money can't go beyond that. So you're always going to round to the nearest penny when it comes to money. So here's another example using compound interest where we're solving for something. And this, for instance, for this one, we'll be solving for time. So there are 2 things that are a little bit difficult on this. So we want to figure out, we want to find the number of years it's going to take, so we don't know, for $500 to be deposited in an account at a 4% interest compounded semi-annually to double. So what we're going to do is we're going to use our compound interest formula, and that'll be given to you. And we want to say our A is going to be equal to 2 times 500. Well, where did I get that? It's because it's saying how long will it take my original amount to double, which is 2 times of that. My P is that original amount, 500. My R is 4%, so 0.04. And my T, I don't know what my T is, that's what we're solving for. And my N is semi-annually, which means every 6 months, and there are 2 sets of 6 months and 12, so 2. So then when I plug everything in, I'm going to get 2 times 500 is equal to 500 times all of this. So now we're solving for this. And remember, this kind of looks like what we've done in our meeting level where we're solving. So the first thing I want to do, I need to get all of this by itself so that I can use logarithms to solve. So the first thing I'm going to do is I'm going to divide both sides by 500. Wait, what did I? Oh, no, sorry. The first thing I guess I'm going to do is figure out what's inside the parentheses. Then I'm going to divide both sides by 500. Sorry, it doesn't matter. You can do either one. Okay, so once I divide both sides by 500, now I've got something that looks like I can solve it. So what I'm going to want to do is I'm going to want to take the log of both sides. And if I take the log of both sides, I'm going to use that property, property 3, which was taking the log of both sides. And then I end up with the power rule, which says that I can take this and throw this out front. Well, now I want to kind of look at this as its own entity, and I want to get it by itself. And if I get that by itself, then I'm going to divide both sides, and this is going to equal, I don't know why it disappeared, equals 2t. So then I have log of 2 divided by log of 1.02. Then I want to divide all of this to get the t by itself, divide all of that by 2 again. And when you do that, you end up with this. So you divide by 2, and then you get t is equal to 17.50. Well, now here's the part that I'm going to ask you to do in the test. Now that we know what it is, tell me what that means in context to the original problem. So if we put that in the original, it was saying find the number of years. Well, if t equals 17.5, then it'll take about 17.5 years for $500 in an account paying 4% interest, compounded semi-annually, to double. So that is all we're asking you to do. We are just asking you to take a formula that we gave you, put it into context, tell us what it means. If you're solving for something, you may be solving for the ending balance like we started with, or you may be solving for a particular variable or one part of the formula, but make sure you can do that. And if you have any questions, please come into class and ask myself or Ms. Wadley. Otherwise, I hope you all have a great day.